Okay, so the adipose tissue, again, when you look at different tissues, you want to be able to draw a picture of it, describe it in a picture, identify where it comes from, and then what its main function is. So when you look at adipose tissue, its appearance looks like little what's? Diamond rings. Did that help when you were looking for it yesterday? It's kind of hard to unsee it. And then in between, so here you have the diamond ring, there's the ring part, and there's the diamond. All of these things over here that are red are actually blood vessels. So something to think about when you're gaining fat or you're getting fatter. To keep that tissue that's alive, you have to provide blood to it. So the more fat you have, the more the blood vessels grow. What's going to happen to the heart when you have more or longer distance blood vessels? It's going to have to pump harder. So as you gain fat, of course, your heart has to push harder. Does somebody just leave, or does somebody come in? And the locations, you pretty much know wherever they are, because they're the places that you complain about when you look in the mirror, right? So, well, not every place, I guess. But around the heart surface, when you look at the love handles, the butt cheeks on women and men, they store them differently. So women have a tendency to store more fat on your thighs and your buttocks, where men usually store it more along the love handles. Places you don't see, the heart surface and around like the kidneys for cushioning. Because your kidneys sit all the way at the back of the back, and only part of them sit underneath ribs, so they have that padding, that extra padding for fat. Your eyes have fat all around them. If you pull that all out, your eyeballs would just sit down in there and rest. So you need the fat. And then the functions for energy storage, it's fat. Fat's like the best source of energy. It's not the fastest source of energy, but it's best because it has the most calories or the most energy potential. Insulation, and of course keeping us warm. And that's always my excuse. I'm starting to put on extra fat for the winter time, just so I make it. Right, so you want to be able to do those things. Describe, function, location, and draw it. Right, next two tissues. So dense regular and dense irregular. When you look at them, the regular, I mentioned this yesterday, but it all goes in the same pattern. So here you can see that lines up with that, with that, with that, all the way through. And these randomly placed spots, those are cells. So this is still, all of this is still connective tissue. You're just looking at a pattern this time. Regular patterns, irregular patterns. So here you can see some of the collagen. There's a long collagen strand. Comes all the way around. Looks like it ends here. Looks like it ends somewhere around in here, but it doesn't actually end at either of those places. Here's another strand. Here you see one that kind of comes out towards you and then goes back in and sinks back in. Remember, when you're slicing across this, you cut the top layer off and you peel it off, and you take another nice thin slice and you peel that layer off, and that's the layer you use for the slide. So some of these fibers will be coming towards you, and then they cut them off so you see the ends, and some of the fibers will be going right along with it. So some of these, since they bend, you'll see just the top here, and it disappears and disappears. Always think three-dimensionally. So with this one, if you looked at the pattern, all of these fibers, would you say that's regular or irregular? Are they all going the same direction, or are they all going different directions? They're all going the same direction. So here's an example of regular fibers, and this is a tendon. So here's the muscle attached to the tendon, and that tendon, all the fibers go in the same direction for strength. The muscles only pull. That's all they do. They pull, and when they relax, they let go. As you're pulling, all that tension has to go into that tendon, and that tendon focuses everything down to one point on the bone. So it has to be really, really strong. When you look at them, these little tiny cells down here, the fiber, what are they called? The things that are making the fibers? Fibroblasts, yeah. The fibroblasts, you have one here, and then you see nothing in this whole area. You see a little piece of one there. But they're thin, they're narrow, and they're basically like little tiny spiders that are weaving these fibers. Oops. I also forgot to mention scarcity of blood vessels. Not that they're avascular and have no vessels at all, but they're very scarce. So what's that tell you if you rip one of these tendons or ligaments? They don't heal very fast because they don't get oxygen and nutrients. Another example with dense regular, and then two good locations, tendons and ligaments. They don't all have to look exactly the same, but you can see the pattern with all these fibroblasts, there are a lot of them, and if you look at the pattern, they're all going in the same direction. So you should be able to describe that, explain its function and location. And dense irregular. Looks like kind of like a tie-dyed shirt, I guess. It's all swirly, like if you put a dye in water and just swirled it around. But the fibers go in lots of different directions. Like I said before, this one you can see it looks like an end, looks like another end. What it's actually doing is it would curve around. When you clip it off, you're just catching that very end of it. It doesn't stop there. It keeps going. When it looks like it's just a round circle, it's because you cut across the collagen and you're looking right down at the very end. If I had fibers coming out like this and another one going up sideways, going through, if I slice this, I would see just the ends of these two, and then I would see the whole length of the one standing up. Whoops, I can't hold it like that. So I'd see the whole length and then two round circles down at the bottom. But again, you can see the cells. There's a cell, there's a cell, there's a cell. They're all over the place. And then here's a hollow area and lots of little red dots. What do you think those are? It's a hollow tube. You're looking into it, and little red dots. What do you think you're looking at? Yeah, blood vessel, which is labeled there. But what are these little red dots? If it's a blood vessel, they're probably red blood cells. And some of the locations, deeper dermis, so deep in the skin. The most superficial layer of skin, and we'll look at this over and over again today and tomorrow. The most superficial, that one's good. All the cells go in a pattern, straight across, holding hands. Then, at the very bottom of it, there are lots of fibers going all over the place. And you looked at this the other day. They're just going different directions. You have a cell there, maybe a cell down here, one up here, one here. This is epithelial tissue because all the cells are holding hands. This is connective underneath. It's holding down the epithelium. But this have fibers that go just randomly placed, and you can see lots of empty spaces all around that are filled with, what's that stuff called? The jello-like stuff. The ground substance or the matrix. So you have all this space around here. So would that be dense or loose connective tissue? Lots of space. And that was areolar tissue. And then below that, then it starts getting thicker. And I can't take the time to draw all the fibers, but they're all over the place. They're not spaced out as this up here. They're not all holding hands like this up here. So these are also connective tissue, but deeper under the skin. And since they're so tightly packed, we call it what? Not loose, dense. And since the fibers, you can see some are going this way, some are going the opposite way, some are going down, some are coming out at you. Would that be regular or irregular? Irregular. So you can just keep putting words on to describe the tissue. Superficial layer of skin, which means closer to the surface, just underneath it where you have blood vessels, and then even deeper where you have that real thick collagen. So here you can see all the cells lining up, holding hands. And then just underneath that, it's kind of spacey all over the place. And you see lots of little random specks, like white blood cells, mast cells. And then underneath that, it changes its texture again. And here you see lots of these dense fibers. Shouldn't say dense. Thick fibers going back and forth all over in these different directions. So loose, irregular. And its function, with the regular, all the fibers are going in the same direction, so you get a lot of strength going in one direction. But the problem is that if you hit that from the side, it doesn't hold the impact as well. Or if you pull it from the side, it has a tendency to rip. So why would you want all these fibers going in lots of different directions? Stronger in lots of directions. So underneath the skin, your skin doesn't just pull in one direction. You can pull it forward, backward, up, down, left, right, straight up in the air, push it down. All these fibers are going in lots of different directions for strength in lots of ways. Not as strong as a tendon or a ligament, but it's still pretty strong. So what would this be? Regular or irregular? Yeah, that one's regular. You can see with all the patterns, they're all going in the same direction. And then the next under connective, so supporting connective tissues, and actually the last. So these are not packed with lots of fibers. They still have matrix, ground substance, but it's a little bit different. So we're going to talk about cartilage and bones. And bones, I said the other day, when you look at them, they look kind of like ring structures, like a tree. It helps identify it. Cartilage typically looks kind of glassy or glossy. And you see all these little cells that are in special little air pocket areas. or not exactly air, it's a water-filled or fluid-filled pocket, but it looks like a little bubble, and that helps you identify cartilage. So just like this. To me, this looks like water or jelly. And here you see that little bubble with the cell in it. There's a bubble with the cell in it. Another one. These little cells, when they're making cartilage, they're called chondroblasts. Chondro refers to cartilage. So what would you call, instead of a cartilage maker, just a regular cartilage cell? Chondro, and then the site on. Yeah. So chondroblasts are the makers. The chondrocytes are the ones that are mature. Chondroblasts usually sit towards the surface of the cartilage because they're building brand new cartilage. The chondrocytes sit deeper, and what they do is they surround themselves in this little fluid bubble called lacuna. And I always think little lakes, so it's an identifying characteristic of cartilage. Cartilage is avascular, so if you rip it, what's the problem? It doesn't have what? Blood vessels to heal. So it doesn't bleed, but it also doesn't heal very well either. And there's another example of the lake. And your body, all of your body before you were born, actually when you're early development to about 4 or 5 months, it's all cartilage skeleton. So you don't have any bones, it's all cartilage. Sharks are the same way, they don't have any bones in their body. Another interesting thing is that when cancers grow, cancers need blood vessels. So you don't get cancers wherever you have avascular tissue. Like the cancers in the surface of the skin, up at the very top, it's avascular. If you had a cancer way up there, it would just die and fall off anyway. But there was this thing, gosh, it must have been the late 90s, where people were killing sharks and grinding up the cartilage in the sharks and selling to people as a cure for cancer. Because they said, well, sharks never get cancer. And in reality, sharks actually do get cancer. They just don't get bone cancers or anything that has to do with the cartilage. So, 3 types of cartilage. Hyaline. Hyaline means glass. So that's the one that's going to be the glassiest looking one. So if I look at all 3 of these, one that looks most like stained glass to me or glass is this bottom one. Elastic cartilage, guess what its perk is? Yep, you can stretch it and it lets it snap back. So like when you pull on your ear, the cartilage in your ear, and you let go, it bounces right back. And then fibrocartilage, it's a little bit stronger because it actually has some fibers that go through it. So the first one, the hyaline cartilage, and again, glassy appearance. It looks like glass. You can see all these little cells and all the little lakes, the lacuna that go around them. And a lot of times you'll see not just one cell in a lacuna, but you'll see a little bundle of them at the same time. And then I didn't highlight this or anything, but you might want to highlight this word, perichondrium. Anytime you see chondro, it's referring to what? The cartilage. When you see the word peri at the beginning, it means a perimeter. So something around. So if there's a covering that wraps around cartilage to protect it, it's called the perichondrium. And it's telling you literally it goes around the cartilage. It's not cartilage. It is connective tissue, but it's not cartilage. It's that dense, irregular tissue. And then I mentioned this already, but place you find it, it's most the skeleton and fetal skeleton. Until a couple more months before you're born, then you start turning that cartilage into bone. And we'll talk about bone in a few weeks, maybe even at the end of next week. But bone's kind of interesting because you started as cartilage, even as up to your teenage years. You still have cartilage right at the tops of the bone, and that cartilage actually makes the new bone to make you grow during puberty. Let's see, it attaches ribs. So when you look at a rib cage like this, you have all of this cartilage through here, which is fake on this, hold it together. But it gives you the ability to flex the rib cage a little bit when you breathe in and breathe out. So if you look at a skeleton like that over there, everywhere you see those glassy looking discs, that's all hyaline cartilage, or would be hyaline cartilage in you. The sternum connects to the ribs. I just pointed that out. And then you have a thin layer of joints, which we'll talk about when we talk about bones. And the functions, it's glassy, it's glossy, it's great because it's low friction. That's one of the reasons you see it at the ends of bones, so they can pivot really well. Helps support the vocal cords. It's a little bit flexible, just a little bit. there's the picture from your textbook. The next one's the elastic cartilage. A couple places you would find it. Ear, like I said, you pull on it, you let go of it, and it bounces back. And also the epiglottis in your throat. It's a little flap that covers over your trachea so that you don't inhale food particles. So here's a slice of the epiglottis, a little flap. They could have done the ear. It looks very similar. You can see all the elastic cartilage all the way up here, and you have that protective covering again. What was the protective covering called that went around the cartilage? Perichondrium. And then functions, it's more flexible than the other cartilage. And then I already played it with my ear to show you. And the last one, fibrocartilage. So fibrocartilage because there are fibers in there. You can see all the fibers going back and forth. Here are some fibers going over, some going up. And then you still see the lacuna, the little lakes with the cells on the inside. This one's an exception to the rule. This one doesn't have perichondrium. The fibrocartilage is strong enough, it doesn't need the protective wrapper around it. So places you find it are places that usually have some movement, but they need to be really strong. So the pubic symphysis. You have two pubic bones. They come together, and right where they come together, the meeting is the symphysis. The pubic symphysis. There's a little bit of flexibility, especially if you're having a baby. And then in between each of the vertebrae going all the way up, you have a thing called an intervertebral disc. All fibrocartilage. They're strong, but they give a little bit of flexibility or bend. So strong, but give a little bit of flexibility or bend. And then we kind of already talked about these. The last few connective tissues, blood and bone. So blood's very supporting. The term connected with blood is really loose. And a lot of people would say, just remember that blood connects all the parts of the body, which I guess I could get that, but it's different than all the other connective tissues. It's a fluid connective tissue. So the blood and the plasma. And then bone's more dense and hard, not nearly as flexible as all the others. So again, with bone tissue, when you're looking at it, they look kind of like trees. You slice across, you can see those trees. There's a tree. There's a tree. There's another tree. And we'll talk about this in a lot better detail next week. But you have these little central canals that go right down the middle of it to give it oxygen, nutrients, blood flow. Nerves can go through there. Lymphatics for your immune system can go through it. And of course, bone's good for storage of what? Calcium. And then blood I already mentioned, but the blood, the plasma is the fluid part, and then the cells that go in it. Red blood cells, white blood cells, you can see these little platelets that are in here. And it's in blood vessels. It always stays in blood vessels unless there's a problem. If there's a problem, you break blood vessels, you start bleeding. If you bleed under the skin, what do we call it? Anybody know what it's called? It's called a hematoma. If you get smacked in the arm really hard, what do you get there? A bruise, and it's a hematoma. So you see it at first it's red in color, and then as it ages a little bit, it turns more of a purple, and then finally that greenish yellow nasty color. And when we get to blood, we'll talk about why those colors change. So next tissue type. So completely different. We talked about epithelium yesterday. We started talking about connective and finished connective today. And what are the two that we have left? Obviously one's in front of you. Muscle and then nervous tissue. And then muscle, there are three subcategories of muscle, or three types of muscle. If you look at them, they have similar characteristics, but they're also very dissimilar at the same time. And there they are, skeletal, cardiac, and smooth. The skeletal, the name's pretty simple. Skeletal moves what? Bones. Yep. Anywhere you see a muscle attached to a bone, that's skeletal muscle. Like, for instance, your bicep or tricep. Cardiac would be where? Heart. Yep. So skeletal moves the body, cardiac moves the blood, and then smooth moves everything else. Any of the hollow organs in your body, like your GI tract, your uterus, urethra, Any of the hollow structures are surrounded by smooth muscle. We'll talk about each of those when we get to muscle. So some of the characteristics, when you look at skeletal muscle, it looks like long tubes. You can see this one long tube going the distance of the slide picture. Another long tube, another one, another one. They're really well organized. So they're usually, not always, but typically all the fibers are going from one area straight to another one. Sometimes you get them splitting off, but when you look at them under a microscope, all of them are going almost practically in the same direction. Another unique characteristic of skeletal muscle, these little things are nuclei. So one cell, this cell goes all the way across the screen here, can have multiple nuclei on it. Lots of nuclei. When you look at it, how would you describe that, just that one tube? Looks like a tube, and it also has stripes. Yeah, we call them striations, so they're striped. And then finally, what it's for, muscle tissue, or skeletal muscle tissues to move skeleton. I'm going to skip over cardiac and come back to it and go straight to smooth. Skeletal and smooth, when you're trying to remember characteristics, skeletal and smooth are almost exactly the opposite in every case, other than being muscle. So if I tell you that skeletal muscle has lots of nuclei, what do you know about smooth muscle? It has few. In fact, it has one. If I tell you that skeletal muscle has to be voluntarily controlled by your brain, what do you know about smooth muscle? It's involuntary. You don't need your brain involved for a smooth muscle to work. If I tell you that skeletal muscle is a long tube, then you'd know that smooth muscle is not long tubes. They're actually spindle-shaped. Spindle, think of a kite. If you've ever flown a kite, you've got the string that comes along and you have that little stick. As you wind the string around it, it starts here in the middle, it gets thicker, and then it tapers off as you get closer to the end, where the bulk of the size is right down the middle. That's spindle shape. So when you look at a smooth muscle cell, spindle shape, with one nucleus. If I tell you that skeletal muscle is striated or has stripes, what do you know about smooth? It doesn't, yeah. There are no stripes. So watch for those characteristics. Where you find, I mentioned all the hollow organs in the body. Blood vessels, hollow organ. Even though they have blood in them, they're technically considered a hollow organ. Smooth muscle. Your GI tract, all the way down along there, smooth muscle. Your renal pathway for urination, your reproductive pathway, all smooth muscle. They're all hollow tubes. And I say cardiac's in between because if I tell you that skeletal muscle has certain characteristics and smooth muscle has the opposite, cardiac actually falls in between. It will take on characteristics of both. Like, for instance, how would you describe this? Does it look like a spindle or a tube? Yeah, it looks kind of tube-shaped. But it branches. Like those little spindle fibers would go up and down and branch off. Cardiac has both characteristics. It's long and tube-shaped, but it actually branches. What else would you say about this description? It has stripes, so it looks like skeletal muscle. Cardiac muscle, can you voluntarily tell your heart, stop? So what would that be, voluntary or involuntary? Involuntary, like what? Skeletal or smooth? It's like smooth. So part of the characteristics of smooth, part of the characteristics of skeletal. There's one unique feature that cardiac has that neither of the others have, and they're these really dark lines called intercalated discs. Intercalated discs. It's a unique characteristic. If you can find a unique characteristic of any type of cell, you definitely should write it down. Because if you get a slide and you're looking at it and you go, I can't tell what type of cell this is, and you see an intercalated disc, you automatically know it's a what? Cardiac muscle cell. And the last tissue. So muscle is pretty simple. Nervous tissue. And remember, a tissue is a group of cells that are working together for one main function. So just saying a neuron is not nervous tissue. It's got to be a lot of neurons plus other cells that work together. There are two types of cells, or two categories of cell inside nervous tissue. One's a neuron, and it's the primary cell. It's the main cell that does the communicating. A neuron can be 3 feet long. So a little teeny tiny cell that you can barely see with the naked eye, or even not see it with the naked eye, but it can go 3 feet long. Like, for instance, the longest cell in the body starts at your tailbone and goes all the way down your leg, down the lower leg, and then to the toe. about 3 feet for most people. And it's a neuron. So they have a body where they have a nucleus where they can make proteins, carbs, modified fats. But when you trigger this body and you activate it, it's like flipping a switch. It can send a signal down this long axon, and that little tube that comes out of it, all the way down to your toes, to your fingertips, to wherever you want to control, and then control that structure. So a neuron's a specialized cell, and it sends something called an action potential, or a communicating signal. Everything else that's around neurons that supports them are called glia, G-L-I-A. So glia means glue. You'll hear them called glial cells. You'll hear them called neuroglia. But watch the G-L-I-A. It means it's the glue that holds everything together. So in this situation, here you have the neuron itself with its big body like this. So what's this dark thing? Yep, it's a nucleus. It has all the organelles surrounding it. It has input areas that bring the signal in, and then when this decides what to do with that signal, it sends a final signal out through an axon, the long structure that would go to wherever you're trying to control. All these little cells around, so there's a cell, there's a cell, there's a cell, there's one, here a little bundle of them. They're all spread out all over the place, and they're supporting, they're taking care of the neurons. So those are the glia. And then neurons don't all look exactly the same. So this one you can see looks kind of naked on the surface, but there's this long axon coming out. And so those are the 4 types of tissue. Different tissues that work together for one common goal, what do you call that? And so one from an organ. It goes from molecules or atoms up to organelles. Organelles that work together form cells. Cells that work together form tissues. Tissues that work together form organs, like this. If you look at just the stomach, you've got epithelium, the protective covering that lines the inside of the GI tract. You've got blood flowing through it, which is a what? Which tissue? Is it nervous, epithelial, muscle, or other? It's blood would be other. Yeah, didn't fall into the other groups. Nervous tissue to help control the stomach, to speed it up or slow it down. Loose connective tissue just underneath the epithelium, and then muscle that helps it contract to smash food. It has all 4 tissues in it that work together for one function, to process and store food. An organ. The stomach doesn't work alone, so you have the whole system. You have the mouth, the tongue, the teeth, everything. The esophagus going down in the stomach, to small intestine, weaving around back and forth, to the large intestine, and then finally out the rectum and anus. So that's an organ system. No organ systems can stand alone, so then you have to put it together with other organ systems to make an organism, and that's us. Let's do this. We're going to look at some blood and some cartilage. So that paper you were working on yesterday, pull it back out and grab your microscope key. Put them up here. I put blood up here. Put neurons up here. Bone and muscle. And I just have a few of the cartilage, so you can look at the cartilage if you want. They're up here. But do these 4. Yep. And if you need more paper,